In this video, we will take a look at the transformations of graphs. There are three types of transformations that you need to be aware of at the SL level. There are translations, reflections, and stretches. The first, translations, there's the vertical translation. So if you look at a graph y equals f of x, and then translate it to y equals f of x plus a, the plus a will move the graph vertically up the y-axis by the value a. If a is negative, it moves it down the y-axis by a scale factor minus a. A horizontal translation, if the graph goes from y equals f of x to y equals f of brackets x plus a, if a is positive, it moves it to the left by a value a. If a is negative, it will move it to the right by a value minus a. Reflections in the x-axis. If y goes from y equals f of x to y equals minus f of x, the graph is reflected in the x-axis. If the graph of y equals f of x goes to the graph y equals f minus x, it is a reflection in the y-axis. And the third lot, the stretches, if y goes from y equals f of x to y equals a f of x, it is a vertical stretch. In other words, the graph is stretched along the y-axis. And if the graph by a scale factor of a, and the final one is the horizontal stretch. So if the graph goes from y equals f of x to y equals f brackets a of x, it is a horizontal stretch, whereas it is stretched along the x-axis by a scale factor of 1 over a. The best way to look at these is to do a few examples using Desmos.
I have opened Desmos. I've drawn myself an unusual graph. The graph f of x equals 4x plus 4 divided by x squared minus x plus 3, or added plus 2. Doesn't matter what graph you've got, this works for any graph. I just like the shape of this graph. It's unusual and you can then see everything that happens. So if I go and now draw f of x plus 3, as you notice, the graph goes up the y-axis by 3 units. So every point on our original graph is moved up 3 spaces up the y-axis. If I change that to minus 3, every point is moved down the y-axis by 3 units. If I put the 3 inside the bracket and make it plus 3, the graph is moved to the left by 3 units. If you notice, the maximum goes from there to there. If I change that 3 to minus 3, it is moved to the right. So if it is inside the bracket, it does its opposite. So if it's plus 3, it acts as if it's minus 3. And if it's plus 3, you would expect it to go to the left, but it actually goes You would expect it to go to the right, but it actually goes to the left. Now if I do my reflections, so if I make it minus f of x, it's a reflection in the x-axis. If I make it f of minus x, it reflects it in the y-axis. And now if I do my stretches, so if I make it 2f of x, if you notice, all the points are, all the y coordinates of every point are stretched by a scale factor of 2. So that point is 0, 3.33, and it's moved to 6.667, which is a scale factor of 2. If I put the 2 inside the bracket, all the x coordinates are halved or multiplied by a scale factor of 1 over 2. Right? So if it's in the bracket, it does the opposite. Instead of multiplying by 2, it divides by 2 or multiplies by 1 over 2. Doesn't matter what you do. So if we do a scale factor of 3 inside the bracket, it is squashed along the x-axis by a scale factor of 1 over 3. If I put the 3 outside the bracket, everything, all the y coordinates are multiplied by 3. If I made it minus 3, or let's see minus 2, because it is not only everything multiplied by 2, it is also reflected in the x-axis.
Let's go through some examples. The diagram below shows the graph y equals f of x. On the grid below, graph the given new functions, label the new positions of a and b, so that is a, that is b, and the axes intercepts if possible. So we want to graph y equals f of x minus 2. That means all the points on the new graph are 2 below the original, so everything goes down 2. So minus 3, 3 will now be at minus 3, 1. 0, 6 will now be at 0, 4. 1, 7 will now be at 1, 5. And 8, 0 will now be at 8 minus 2. So if we draw those nice so our new graph will look like this. So that is the graph of y equals f of x minus 2. For the second graph, we have to graph y equals f bracket x plus 2. Because it's inside the bracket, it does the opposite, so everything will go 2 spaces to the left. So there's A and there's B. So A will go from minus 3, 3 to minus 5, 3. So it will go there. 0, 6 will go minus 2, 6. 1, 7 will go minus 1, 7. And 8, 0 will go to 6, 0. So if we now draw those in, so let's change the colour slightly to blue. So we go along there, we go up there, and now we go down to there. So that is the graph y equals f of x plus 2. In this one, we've got to draw the graph y equals 2f of x. So that means all the y coordinates are multiplied by 2. So let's put a in again, put b in again. So a will go from minus 3, 3 to minus 3, 6, which is there. Zero 6 will go to 0, 12, which is there. 1 7 will go to 1 14, which is there. And 8 0 will stay as 8 0. If we now draw it in, we'll get that line going along there and up here, and then this line will come down here, go through this point, and that is the graph of y equals 2f of x. The next graph we're going to draw is y equals f of 2x. That means that all our x values are halved or multiplied by a scale factor of 1 over 2. So minus 3, 3 becomes minus 1.5, 3. 0, 6 stays as 0, 6. 1, 7 becomes half 7. And 8, 0 becomes 4, 0. So if we now draw in, this line will stay the same. So we'll go along there. We will go up there. And then we will come down at this point here. So that is the graph of y equals f of 2x. The next graph we're going to draw is y equals minus f of x. And the minus means that we are going to reflect it in the x-axis. So minus 3, 3 becomes minus 3, minus 3. 0, 6 becomes 0, minus 6. 1, 7 becomes 1, minus 7. And 8, 0 becomes 8, 0. It stays the same. So if we draw that in, goes along there, down here, and then up there. And that is the graph of y equals minus f of x. And the final graph we've got to draw is y equals f of minus x, and that is a reflection in the y-axis. So 1, 7 becomes
minus 1, 7. Minus 3, 3 becomes 3, 3. 0, 6 stays the same. And 8, 0 becomes minus 8, 0. So if we join that up now, that will go down there. This will go up here. And then we will join that along there. And that is the graph of y equals f of minus x.